Welcome back, guys. Welcome back to Everything is Swift. So let's check the Leetcode question. So the Leetcode question is under the 1000s. So Leetcode 474. So the question of the title is the ones and zero. So we're given an array of a binary string, which is the STRs, and then two integers, m and n. That's the three artifacts for our solution parameter. And we have to return the size of the large subset of strings such that there's at most m zeros and n's represent the n's in the subset. A set of x is a subset of a set of y if all element of x are also element of y. So what do we do? In the input, okay, let's check together. So in the input, we are given by the binary numbers array, but even though it is represented in the string, that is the binary version. Then let's check together the length. So it is in the manageable scope 100 1 to 600, and then the length of the string will be 1 to 100, and then the strings only consists of 0 and 1. So and then we can consider m and n is within the range of 1 to 100. So if I have to dry run for this kind of asymmetry, so we have string like 100001, and then there's a number. So what do we want? We want m5 and n3 in here. So n represent the 1, and then m represent 0. So we want 50, which is 1, 2, 3, 4, 5. So that means we can take these 1 for sure. And then n is 3. So 1, 2, and 3. So we can only take the index of the array if it is both or all the items in the index is chosen. So why do we not choose this array? We still can consider. So that is the reason why we written it output of 4 here, according to the previous dry run. If we go for the current dry run, so we want the 50. So let's consider we take this 2 and this 3, which is 5 of 0, but we only want that 3 ones, so we're gonna take this for sure and not this for sure. So that is the reason we're choosing the largest binary numbers in here. And then for the asymmetry 2, that is also straightforward. So we have to choose like 1, 0 and 1, 1. So we can consider we can just take this, but the thing what we want is we want the largest subset. So that is, if we choose the 1 and 0, that is the smallest subset, which is a 1. So we want the largest subset, which is a combination of 0 and 1. That's why we choose this. And that's estimate of how the solution works. I think for this problem, I think we can use using the memorization approach. Yeah, that's what I can think for now on. And then, yeah, with the depth search, since we are going to iterate through all the items one by one, and then we can see through like which one is working properly. So let's see how it's work. Let's say like we want to use the dictionary for memorization. Let's consider this is a why the font is so small here. All right, change to black. Let's call like we use a dictionary with the key of index, which is we need to keep track of which index are we at for the string array, and then m and n, and then we want to keep the values. So to go through, first what I'm gonna do is every index, I want to know like how many zeros and how many ones in each item. After that, I will go through it by measuring it. How do we do? Let's call like create the table in here. Okay, instead of writing a discrimination, let's call this index. Then we have a 0 index, and then we have another one called string, which is a 1 0. And then let's use this XML in here. So we will use the XML of 10 0 0 0 1, and then 1 1 1 0 0 1 and 0. So that's what is our initial idea. So I want to calculate like how many zeros in here and how many ones in here. So let's calculate. Since we have a string of 1 0, we got 1 0 and 1. And then next step is we calculate like index of 1. Alright, this is much better, easier to control for me. And then for this one, that will be like 0 0 0 1. So that's also pretty straightforward. We got 3 0 and then 1 1. And then for the index 2, which will be the 2 in here, and then we have a values like 1 1 1 0 0 and 1. I forgot the 1 here. That will be the 4, but yeah, 2 0, only 4 ones. Okay, let me draw one arrow for you guys to make it clear. Right, that makes sense. And then index of 3. So 0 1 2 3 is only value is 1. How many 0? 0 0. Just copy this and then paste in here. No, just paste in here. And then this is 1. So for the index 4, that's also very straightforward, which is only 1 0. Let me 1 0 and then 0 1. Hope you guys got that approach. So what do we want to do is every time we call our default search, we're gonna pass our index. So yeah, we are going to calculate it. So let's call very first our index. Let's call like we're going through using the default search. So we need a base case for that. So for the base case, that will be I need the string count. So if the index is same with this count, we're gonna return it. Return 0. This one is important because we want to check the base case. So since we iterate through, so what we're going to do is very straightforward. We will pass the 0 first and we compare the count is 0. And then here is the count is 3 4 5. 5 equal not equal to the index for sure. That we can iterate through. And we will calculate the index of the I and M and N. And then we're going to keep in the cache. If it is in our dictionary memorization, we're going to return that value on the spot. If not, we need to calculate the best. So for the best, we just return the +1. So we should be the stuff from the index 1 because we just want to calculate the index from the iterative approach. Okay, let's write through it since I have talked a lot. For this, I think I can prepare the count first, which will be the calculation of 0 and 1. Let's call it string. And then it will return the 2 tuple. Yeah, 2 tuple for sure. And then what we're going to do is we're going to reduce the string into 0.0 for the base case, and then we will need like 2 parameters here, which will be like total and character in. For this one, I can simply check if the character is equal to 0. Just we're gonna do is yeah, total dot 0. I think it's not total, we should better call it like a accumulation. Yeah, accumulation of 0 plus equal to 1. If not, accumulation of 1, which is actually 1, that's equal to 1. Yeah, that is for the count. And then we need to make it memo, which is for the memoization. And then that would be like 3 tuple as a key, and then this is a value. I think since these 3 tuples are not confounded with the hashable, how about we create the, I was thinking like creation of the custom strings, which is easier for us to use. Yeah, I think that's a better approach. So to create the custom threads, let's call like create in a path in here, much better. Let's use like stress key, and then that will be confound with the hashable, so that we can do the hashing for our key. So we need the index, and then we also need the m, which is also integer, and then we also need the n, which is also integer. So in that case, we can simply use key as our key. So this is where our memoization comes in, and then I can just create the depth search. I think for the depth search, how can we use the depth search here? Let's think about it. So we definitely need the index for sure, which is same as the parameter. I will call it as integer data type. And then next will be the m, which is similar to the parameter above, which is also the integer type, and then which is will be the n. And then we're gonna return the n in here. So if we are planning to return the integers in here, so what we want to do is we need to calculate the base case that I was mentioning here, that will be in here. So if our index is equal to the total inputs count, or we just return the 0, that will be the base case for us. And then we check the key. So since our key is a tuple, we can simply use like I will be the index, m will be the m, and the n will be the n. So which is a direct translation of this one. And then after we receive the key, what we can do is we can check in our cache. Let's call like cache value. If our key is exists in the memo, we can just return our cache. So which is will save a lot of performance for us. And then next we need to do is we have create the 0 and 1 tuple, which we can receive from counts of index. So that means like every time we pass the index of the string, so that will help us to convert that strings into the number of zeros and number of 1. And then we can start calculate our best. So best will be by using the default search of the index plus 1, since we want to go through the next item in every time we call the default search. And then for the m, which is represent the 0, we're gonna remove the 0. Why we need to remove the 0? Since we have calculated how many 0 in this index 0. So that means that we already used this 1 0, so we are deducting in here. The same for the 1. So every time we press back to our default set, we're gonna detect our 0. So after we detect, what we need to check is we can simply calculate the best by using the maximize between the best and our another default set, which is index plus 1. Yeah, index plus 1 and m minus. Oh wait, I should do the normal pass m in here and then do the set in here. That's make more sense, because if we calculate the in the top above, it doesn't make sense for us to compare. Set and n minus o, which will be o in here. And then, oh wait, we better check the base case above. Let's so if 0 count is less than or equal to the m count, or our 0 count, our 1 count is less than or equal to n, so that we only proceed this method. Because if we don't calculate, that could cause our m and n to become the negative parts. So we don't want the negative to appear in our default search. After that, we update our key with the best, and then we just return the best. And I think we can just call the default search of the 0 item m and n. I think for the space and time complexity, that will be the O of m and n and string counts. The same for the space complexity, the same for the time complexity. Let's try to run it and see what will happen. Okay, it should be the index. Alright, I think this solve our question and see if solve all the test case or not. Yep, that solved all the test case. And see this m, n, and l is the length of the array. I think the same for the time complexity. Yeah, that's pretty much for it, and have a good one and see you in the next video.